Question 12. Okay, so equation of a circle, and the first part is asking me for the coordinates of A, which is the centre, and the radius. So the standard part of the question, so we complete the square. So let's separate the x squared, the x's with and the y separate. So I got x squared plus 6x plus y squared minus 10y, add 14 equals 0. So to complete the square here, I halve the 6, which is 3. That's going to be x plus 3 all squared in a bracket, and if I expand that bracket out, I've got a plus 9 extra, so I need to subtract 9 to keep the two values the same. Similarly with the y's, if I halve the minus 10, I get minus 5, so it's minus 5 in the bracket, and then when I square this bracket up, the last term will be plus 25, so then I need to subtract 25, so the values are the same. Plus 14 equals 0, and then getting in the format of the standard equation for the circle, take these over, so minus 9 minus 25 goes over to 9 plus 25, take away the 14, that's 34, take away 14 is 20. So the answer to part 1, the centre, A is the centre, so that's minus 3, 5, and the radius is the square root of 20. Second part, I got a point P minus 6, 2. I want to determine whether P is inside the circle, on the circle, or outside. So if I work out the distance of this point P from the centre and compare it to the length of the radius, then I can see where it is in relation to the circle. So the distance AP is the square root so that's 5 minus 2 all squared plus minus 3, double minus on the 6, that's plus 6 squared. That's the square root of 3 squared plus 3 squared, the square root of 9 plus 9, which is the square root of 18. So I can see the distance of AP from the centre of the circle to this point P is root 18, which is less than the radius, so that means it must be inside the circle. Therefore AP is less than the radius, therefore P is inside the circle. Part B, I've got a line y equals 2x plus 1, and it shows the tangent to the circle. So y equals 2x plus 1. Now then what I'm going to do, I'm going to solve to see where this intersects the circle, and if it's a tangent, well, that means I should only have one solution out to the equations. I mean, there's three possibilities with a circle, line in a circle. I just show the three situations. When a line, the circle, three things can happen. The line can cut the circle, you can just touch the circle, or it can miss. Okay, so when you solve the line with a circle, you're always going to end up with a quadratic. Okay, and a quadratic can have three different types of roots. Okay, and it all depends on b squared minus 4ac. In the situation here, when I got two points of intersection out, then I'll have a value for the square root. B squared minus 4ac will have to be greater than 0 in that situation. When it's a tangent to the circle, I've only got one root out, so I need the roots to be repeated. So b squared minus 4ac will have to equal 0 in that situation. And if it misses, it means I can't work out the square root. And that will be less than 0. So let's solve these equations then, and let's see which situation, well, I know which situation I need. Let's see if we get it. So y is 2x plus 1, sub in, that's x squared plus 2x plus 1 all squared plus 6x minus 10 plus 14, this one is equal to 0. So I've substituted in for y into the equation. So let's expand out in correct terms. That's 4x squared plus 4x plus 1 so that's 5x squared. 4x plus 6x is 10x minus 20, that's minus 10x, and I got 1, 15 plus 5 equals 0. Divide by 5, x squared minus 2x plus 1 equals 0, and if I factorise that, that's x minus 1, x minus 1 equals 0. So I got a repeated root of x equals 1. So the situation I've got then, I've got this situation here, okay, say b squared minus 4ac equals 0, gives me real and equal roots. So I get the same root out twice, and that's what's happened here. Okay, so I get the coordinates of x is 1, and y is 2x plus 1, so it's two lots of 2 times 1 plus 1, so y equals 3. So point Q is 1, 3, and because there's only one point of intersection, it must be a tangent. Therefore, since 1 point of intersection L must be a tangent to C. Okay, second part, point R as coordinates 4, 9, R is on L, find AR. Okay, so we need a diagram here to see what's happening. I circle first. So I've got the centre, which is minus 3, 5. L is a tangent. Tangent. That is the coordinate A. This point here, the contact is Q, and I've just got that coordinate to be Q is 1, 3. The point R has coordinates 4, 9, and R is on L, so this is the line L, so R is on the line, that's with coordinates 4, 9. So joining those points up, making a triangle. Got a right angle triangle there. Right, AQ is the radius, and the radius is the square root of 20. And I want angle ARL, I want this angle here called theta, so I need another length. So if I find RQ, then I can use SOHCAHTOA. So to find the length of RQ, that's using that formula. So R is 4, 9, Q is 1, 3. So that's the square root of 4 minus 1 all squared plus 9 minus 3 all squared. Square root of 3 squared plus 6 squared. 9 plus 36, so RQ square root of 45. Okay, this is the angle I want. Right angle triangle, that's your opposite, that's your adjacent. So I'm using the tan angle, so tan theta is over A. Tan theta is the square root of 20 divided by the square root of 45, and then find theta. Just typing that in the calculator. So shift tan square root of 20 on top, square root of 45 on the bottom, so theta is 33.69006753, so theta is 33.7 degrees.